Hello, you are welcome to this video. Welcome to this class. My name is Dr. Kingsley. In my class today, I want to take you on another aspect of chemistry. Okay, that is stoichiometry. Stoichiometry is a branch of chemistry that deals with mass volume relationship in a chemical reaction. Otherwise, it can be referred to as calculations in chemistry. Now, the word stoichiometry comes from the Greek word, okay, stoichio, stoichio. That is stoichiometry comes from the Greek word stoichio and the metron, okay. That is the two terms that give rise to stoichiometry. Stoichio means atom, while metron means measurements. Measurements. If you combine this together, you can see that stoichiometry will mean atomic, okay, measurements. So what it simply means is measurements concerning atom. So measurement involving the mass of atom, the volume of atom, the number of moles of atom, okay, is what we shall be discussing under stoichiometry. Now, having known what stoichiometry is, okay, it deals with atomic measurement, whether it's mole, volume, okay, and whatsoever the measurement concerning atom, okay, that is stoichiometry. Now, but stoichiometry on itself can be divided into two. So we have two aspects of stoichiometry. Now we have stoichiometry of composition. We have stoichiometry of composition. We have stoichiometry of chemical reaction. Now, stoichiometry of composition are those calculations or measurements involving atom when the atom is not undergoing chemical reaction. Okay, that means any calculation in chemistry under stoichiometry where you don't need to balance an equation, you don't need to balance chemical equation before you can make those calculations, they fall under stoichiometry of composition. Stoichiometry of chemical reaction are those stoichiometry or calculations that you need to balance, okay, the chemical equation before calculation. That means there is a reaction. All right. Now, under stoichiometry of composition, we have the mole concept, what we call the mole concepts. The mole concepts is under the stoichiometry of composition. We have calculations involving molar mass. We have calculation, okay, involving percentage composition. All this calculation, you don't need to balance chemical equation before you can, okay, before you can calculate. Then also we have what? Formula mass. Formula mass. Calculations involving formula mass. Remember, formula mass can either be empirical formula. Then we also have what? Molecular formula. Okay. Then you have a water of crystallization. Calculations involving water of crystallization is under stoichiometry of composition. You don't need to balance the chemical equation before you can get it. Then you also have okay, relative atomic mass. Calculations involving relative atomic mass and isotopy. Reactions involving relative atomic mass and isotopy is under stoichiometry of composition. Now, when we come to stoichiometry of chemical reaction, okay, you need to balance the equation of reaction. For example, here we have a molarity. Okay, let me start from the simple. Okay, the simpler aspect is okay, we can take a limiting reagents. Calculations involving limiting reagents. You have excess reagents. Okay, you have okay, others like molarity. Okay, is under this. Okay, there are so many of them that are here, but what I want to do is to take them one by one. That is, I want to start with stoichiometry of composition. All right, taking them one by one, we'll go what in a way that will be what, that will be sequential from one to another. Then when we come to stoichiometry of chemical reaction, I will also list all of them. The board here will not allow me now, and I don't want to clean, so I will take this one and list all of them. We will also take it one by one. I believe that after this class, you will be able to do what, handle calculations on stoichiometry, okay, in a perfect way. The only thing I want you to do is subscribe to this okay, to this channel for you to be following me up. Now we'll go to mole concepts. That is a mole concepts. We want to give the different formulas for what? For mole. What is mole? A mole is the number of elementary entities, okay, that are present, okay, in 12 grams of carbon 12. Okay, the number of what? Entities present, okay, in 12 grams of carbon 12 isotope. Now that is the mole. Now there are so many formulas that we can use to calculate the mole. One of it is that number of mole, will be using n to represent number of mole. And number of mole can be given as mass, or if I like, given mass. It can be given as number of moles is given mass. Given mass is small m, we'll be using, okay, over molar mass. That is number of mole. Molar mass will be using capital M. What does it mean? It simply means that the number of mole is mass, or given mass, over molar mass. That is the first equation we can use, okay, to calculate a number of moles. That is the first formula for number of moles. Number two, we can also use number of moles is given volume. Given volume, that is small v, okay, divided by molar volume. Molar volume will be using capital V. So that is to say that number of moles is given volume, which is small volume, small v, over molar volume. We are using capital V for molar volume. Remember, molar volume of gases at STP, which is capital V, is 22.4 dm cube. That is the value for capital V, which is the molar volume. Then number 3, we can also be using number of moles is equals to concentration in mole per dm cube. Concentration in mole per dm cube, okay, multiply by volume. The volume will be in dm cube. That is another, okay, formula that we can use to calculate number of moles. That is, number of moles is concentration in mole per dm cube multiplied by volume in dm cube. So number of mole is equals to concentration multiplied by what? Multiplied by volume. The concentration is in mole per dm cube, while the volume is in dm cube. I hope you can see the board here. All right. So that is number 3 formula for number of moles. Now number 4 formula for number of moles. Number of moles M is also equals to PV over RT. Okay, this holds for what? For ideal gas. Remember that P is a pressure. P is pressure. So V is a volume. Okay, R is a molar gas constant. Okay, and T is a absolute temperature. Absolute temperature. We can use these 4 formulas, okay, to compute number of moles. So you have seen there are so many other formulas for number of moles, but as we go on, I will be giving you if the need arises. Now, this is mole concept. Remember, mole is number of what? Elementary entities, as it is in what? 12 gram of carbon 12 isotope. Now in my next class, I will be giving you calculations based on these formulas that I have given you now. Subscribe to my channel, share my videos and like them. Thank you very much.